Yeah, I think this reference building approach is a very clear illustration of some of these systemic problems that you're talking about. And that's why I want to spend just a few minutes talking about these latest changes to the DC Energy Step Code and their implications. So just a quick overview for those who are not necessarily involved or familiar with this new performance-based code in DC. So the step code is really looking at the energy performance of buildings in terms of three metrics. One of them is the so-called TEDI, which looks at the thermal efficiency of your building envelope. And it's expressed in terms of the kilowatt hour per square meter annually needed to heat the building for space heating. And that's directly, correspondent to the 15 kilowatt hour per square meter that Rob was mentioning as the universally accepted and adopted benchmark. Then we're looking at the air tightness of the building. So basically the rate of air leakage into the building, which is measured and looked at in terms of the ACH. And then we have finally the so-called MUI, which looks at the mechanical energy use of the building. So the idea here is that in these three metrics in combination give a complete picture of how well the building has been designed and constructed in terms of the building envelope, and then how efficient these mechanical equipment are for running the building and for air conditioning and other services. So now the inclusion of these two first metrics, the TEDI and the air tightness metric, the ACH, is really based on the so-called envelope first approach, which is based on just very basic building science, which essentially means that the best and most sustainable way of achieving energy efficiency and net zero energy readiness in the building sector is to start with a highly efficient building envelope, which is also airtight. So that was recognized in the procedure leading up to the development and adoption of the Energy Step Code. So that was great. This was recognized, and that was the reason we had these three different metrics. Now, what happened last year, last November, and I think coming into effect last December, was that there was a revision to the building code, as is usual every couple of years or every year. And then in that revision, among the changes pertaining to energy efficiency and the Energy Step Code specifically, a new metric and a set of new targets were introduced for looking at the thermal performance of your building envelope. So here in this table, I have. We don't need to get into all the details. I'm happy to discuss that in the question and answer section. But we had these targets for different steps, starting at step 1 and leading up to step 5, which is the stated end goal of the step code by 2032, and that's equivalent to net zero energy readiness. So we had these targets for TEDI, indicator of the thermal efficiency of the building envelope. The first change introduced last year was that the province introduced an adjustment to these targets. And as you see in the table, there is a relatively minor discrepancy, and basically it has become somewhat more lenient, which is cause for concern. But compared to the second change, which was the introduction of these relative performance targets, the reference building approach that Rob introduced, this is the real problem now. And I remember when there was some communication from the building safety and standards branch from the province last year, there was an email saying, well, look, the new revision to the code is coming into effect in a few weeks, and these are some of the changes. And I was going through that, and I was obviously interested in stuff relating to the step code, and I came across these relative performance targets. And I remember I looked at the target for step 2, and I looked at 5%, and I was going, really? How are you even going to measure that? Is it even meaningful, given all the building energy modeling tools that we have to talk about 5% improvement? And that aside, that methodological question aside, is that even significant? Is that going to drive the change that we need to see in our building sector to move toward net zero energy readiness in a span of almost a decade now? So that got my interest, and I started looking into that in more detail. And fast forward into a year later, I have spent a lot of time looking at data from our jurisdiction in Richmond and also other municipalities in our area. And then to just sum it up very concisely, I think this graph will tell what's happening there and what the core problems. So here you see the average improvement in the thermal efficiency of the building envelope that we would get based on the original absolute performance targets. And here we're now looking at steps 2, 3, and 4, just for simplicity, but you can extend the analysis to the entire range from step 1 to step 5. So these were the original targets prior to December 2019, prior to the latest revision to the code. And then those adjusted targets that I talked about, the minor adjustment introduced to still absolute numbers, are making things a bit easier. But then you look at the relative targets, so the intended improvement over the so-called reference house. And then you see there is this major discrepancy between what was originally proposed and put in place, which, as Rob mentioned, is informed by climate science. It's not some arbitrary number that we come up with. This is based on the fact that, the end goal is to achieve 15 kilowatt hours per square meter annually in order to make net zero energy buildings a reality. So you look at that, the kind of blue bars here, and then you look at the red bars, which is what you will get from the new relative targets. And of course, if you have a more lenient target, a more lenient, more easily achievable pathway in the building code, of course, that's going to encourage people to take the easier route. Now, I should mention that this entire reference building approach is not new per se. Even in the original energy step code, there was a similar set of targets and a set of metrics for the overall energy performance of the building, or the mu target for the mechanical equipment that I talked about. So there was a similar approach, which is still, of course, in place. But then, frankly, that was not a major cause of concern, at least for me, because when I looked at the three metrics, I knew that the TEDI is the more important one. And then based on the original targets, it was the more challenging one to achieve. So even though we had the same fundamental methodological problem with the reference house targets or the relative targets in terms of the MUI, that was not a great cause of concern, because we knew TEDI is the real driver of change and is really what we need to achieve for net zero energy readiness. But now, by extending that approach, which is, of course, also the approach taken in the national code, we are really watering down the energy step code. And our concern, as I'm going to go through quickly, is that we're not going to be able to achieve the goals that we have and we must achieve with this current code. Now, just to illustrate the problem and the disconnect that Rob mentioned, and then the discrepancy that we see in these targets now, let's take a look at this graph. Now, one of the problems with this reference house approach is that, as Rob mentioned, this reference house is a fictional hypothetical building where you're in your building energy modeling, you're saying, okay, so I have this proposed design. What if I had built the same house, the same form factor, geometry, orientation, all of that, to the code minimum requirements, the prescriptive requirements of the code? How would have this my house performed had I built it to code minimum? And then you run that in your energy model, and you compare it to the energy performance of your proposed house. And now you compare the two. But then the problem, of course, is that if you change your design, for every single house that you design and intend to build, you're going to have a different bar, because the reference house is a function of the design of your building. So this graph here is showing kind of the histogram, the distribution of reference house thermal energy demand intensities, again, the metric showing the thermal efficiency of the building envelope, from 40 or 39 different houses in the Lower Mainland. So these are all houses of the same archetype. So these are single family dwellings in the same climate zone 4. And now you see that depending on my design, where I'm putting my windows, how much window area I have, what is the orientation of the house, how much articulation I have in the building envelope. I have a very wide spectrum of my reference house TEDI. And so if we're talking about, okay, we now want to see 5%, 10%, 20% improvement, the question is 10% improvement over which of these reference houses? And again, remember, the target, the universally accepted and adopted target is 15 kilowatt hours per square meter. That's the end goal. That's where we need to get in 10, 12 years time. But now, if I'm taking one of the inherently inefficient designs on the right end of the spectrum, where the reference house is performing very poorly, to achieve that end goal means 80% improvement. Whereas if I take one of the more efficient designs, inherently efficient designs, that means around 60% improvement. So you have this very wide gap of what it means in relative terms to achieve our end target of net zero energy ready. And then what does the building code currently propose for step 5, which is supposed to be net zero energy ready? 50%. So that is cause of great concern. And I know Rob has looked at this in more detail in terms of what it means in, in opening this entire process to gaming the system. So I'm going to hand it back to him to give us a few very interesting but kind of scary examples, and then I'll talk about a bit more about some of the actions we have taken. So Rob, back to you.
Okay. Thanks, Sepehr. Yeah, that's really interesting, and seeing the actual data now coming out from buildings that are being built within your jurisdiction, I think is really illustrative and allows the issue to be brought forward. I'd like to just perhaps start with a couple of anecdotes before I speak to this sort of diagram that we've got up right now, and that because I'm going to be speaking now about the reference building approach to show another issue with it. But the reference building approach is thought, perhaps by some at any rate, to be necessary or appropriate because the absolute targets are too hard to hit. But what we're seeing now in BC, and the same issue will come up across the country once the new codes come in, is that the targets under the STEP code are simply, the absolute targets are absolutely too easy as builders are being trained how to build them. And there's interesting little anecdotes coming out. And there was one recently, a builder from a smaller cold climate zone 6 interior community that is has not adopted the STEP code, was saying that he's going to put the homes that he's building, spec homes, he's going to make them step 3. He's asked why, and his answer is because he clearly doesn't need to do that. Why? Well, it's cheaper than what I'm building now, what I have been building. Well, what do you mean cheaper? Well, I can use poorer windows and less insulation. And the market in that community was already demanding more than step 3. The energy model that he's getting demonstrated that he could build step 3 in climate zone 6, a cold climate, relatively cold climate, with windows that are so poor performing, double pane windows, that he would have to special order them. The local suppliers don't carry that level at the moment. And the same thing with insulation. He could get cheaper insulation. He normally gets a little better quality insulation. He could get the really cheap stuff, except it's not in stock, so he'd have to special order it. So he's actually going to do a little better than step 3 because he doesn't want to special order these things. Another one in sort of mid-Vancouver Island, climate zone 5, is building a step 5 house. And again, you can see these steps are starting to be used as marketing labels rather than performance outcomes. And the reason is for a marketing advantage, because in climate zone 5, a home, these are single family homes, they can be built with 2x6 batten poly and R22 walls and cheap double pane windows. That's step 5 in climate zone 5. And they're being sold, they're competitive with the other homes being sold, just run-of-the-mill spec homes. And so the one builder is in an area where a number of builders are active building these spec homes and is going to be doing that. Doesn't take the other builders long to figure out that, hey, somebody's going to be marketing a step 5 home next to my no-name home. I better figure out what it's going to cost to do step 5. And in the designs they're using, they needed to add, I think it was 1 inch of subfloor insulation to their design, sub-slab insulation to make step 5. They don't need an HRV. They don't need a heat pump to do this. But they're putting those items in because they can't sell the homes without them. So those items are marketing pieces, not performance requirements under the STEP code. So 2x6 batten poly with cheap double pane windows, step 5 is not a high bar to get over. It's nowhere near where we need to be. It's only possible because of the different technical detailed inadequacies of the way in which we calculate performance. It's such a loose and easy method right now. So those comments, just briefly, in terms of the absolute targets that we have. The diagram that's in front of you is a diagram of several different sort of theoretical floor plans. We all know that in buildings, a cube is the most efficient sort of form of building in terms of the ratio of wall area or envelope area to floor area. And as we go up in complexity, you get more wall per given floor area. And most passive house buildings tend to be more cube-like, or maybe the 20% more than. That's because it's impossible to, at an affordable price anyhow, reach the performance metrics if you design a very complex building form. This is for small buildings. It's not such a factor with big buildings, but for a single-family home, it's important. Then what most people and most designers don't realize is that the average or normal budget track or spec home is about 150% of the envelope area of a cube. We have fallen into the habit of decorating the home with the envelope. With vernacular architecture, you look at many of the beautiful old buildings we have around here, we decorated the envelope. We put a veranda on, we put a porch on, the garage is beside the house. There's a balcony, there's patios, there's other things to decorate with, but we don't go in and out with the envelope. This diagram here illustrating 150% wall area, the ins and outs are exaggerated, but that's because we're only drawing in the 2 dimensions. There's a third dimension where the complexity gets added on with the ceiling or roof and the foundation or basement. So we're just exaggerating the jigs and drags here in the drawing to show the degree of the increase. But it's absolutely common in cheap sort of track spec homes to have an envelope area about 150% of a cube. And that makes the home very expensive, relatively expensive, because you pay for all of this by the square meter. When you get into McMansions or into custom homes or mansions themselves, the numbers are way higher. You can easily get into 250%, 300, 350%. So the spectrum, the range that we're showing here is a really normal range, other than only a few people build at the efficient end of the range. Next slide, please, Sepehr. So here's a graph illustrating the TEDI that Sepehr was talking about, thermal energy demand intensity. It's the heating and cooling loads for the building. The blue bars show the theoretical amounts of thermal energy that a building complying with different levels of the step code would do, plus passive house. Many people thought when the step code was introduced and identified 15 kilowatts per meter that was passive house performance. In fact, the details are defined differently, and it never was the same. There was initially some thought that the definitions would be improved, so it would be the same. But right now, the Step 5 home in Climate Zone 5 is able to use about double the energy of a passive house. And this measurement here is adjusting the passive house numbers to reflect comparable measurement methods. So with what the orange and the gray bars show are the difference between the reference building performance and the proposed building performance proposed form of building when it's built to Step 5. So the orange bar represents the same house with different amounts of envelope area, and the gray bar represents that same house built to the minimum code. So we can see, beginning with the cube, the Step 5 house is, almost half of what the code minimum would be, which you would expect. But as the envelope complexity increases, so does the energy loads. So that by the time you get 150% of the envelope area, using the reference building approach, that building is permitted to use about double the heating and cooling energy of an efficiently designed building. And that's because for the reference building, you just need to show that you are 1% better than the reference building. And I've forgotten the details. I think it's something like 50% better. Sepehr can maybe correct me, but it's about that. And so at 45 kilowatts per meter, it meets Step 5. And if we go into the custom homes, the McMansions, the mansions, we can't fit it on this chart. So the people that are having to design on a budget and create a simple, affordable home, they need to meet a much higher level of performance than those people who aren't worried about the budget. So the inequity is rather striking. Next slide, please. This is a graph showing, it's a comparable sort of graph, but it's including what's commonly in the Part 9 world in BC called, but it's without wanting, it just includes a broader basket of energy loads, I put it that way. And there it's quite interesting. You can see if you've got a step 5 building in the middle, the 2 columns, the orange and the gray, the cube, the reference building, and the step 5 building are roughly as you would expect. The step 5 brings the loads down by about half. And then look at what happens to the permissible loads as the envelope area increases. If we go to the right-hand side, the reference building, built again the same way as the cube was built, just more envelope area, its energy load goes up to 188. So if you've got to meet whatever it is, the 50, 60% threshold there, I think it varies with building size, then you're allowed to consume like 90 kilowatts per meter, somewhere in that range. And so triple what a cube is allowed to consume. And again, if we get into the more expensive homes, then the numbers are much greater and they don't fit on this graph. So the inequity of this thing is striking. And Sepehr's mentioned the sort of different target for each home, not each archetype. And the targets vary primarily with the complexity of the design. So, next slide, please, Sepehr.
Yeah, thanks, Rob. Before I talk about some of our activity on this in Richmond, I just wanted to go back to this plot that you talked about. I just want to reiterate and bring everybody's attention to the column or the bars on the very right, step 5 cube with 150% more surface. So what's happening here, and this is really the core problem, I think this illustrates the problem very clearly. So under the relative performance regime, what I need to do basically is to lower the bar with an inherently efficient design. So I lower the bar, that gray bar there, 91. I lower it so much that with doing a few basic things, I can achieve 50% improvement, because achieving 50% improvement on such an inherently inefficient design is not going to be difficult. And then I'm going to call it step 5, and then all the marketing advantages that Rob talked about. So I think this is very serious. Now, as I mentioned, we have been looking into this for almost a year now. We recently took a report to the council, and this was received well. So we are now writing letters. We are asking the council and the mayor to write letters to the ministries involved and responsible for this, and we really hope to see these missteps reversed, and then this relative performance approach and targets stricken out of the step code.